Hello! In this video, we'll continue looking at hazards in the pipeline processor, this time focusing on control hazards. So remember, a control hazard takes place when we don't yet know what instruction to fetch at the time we need to fetch it. So this particularly shows up on an instruction like branch on equal. The branch, we don't know whether to take it until the execute stage, because that's when we compare the numbers and see if the result is 0. But there are instructions that are fetched after the branch is issued, and these two instructions must be flushed if the branch is taken. So let's see that in the pipeline. Suppose we had a branch on equal. If S1 was equal to S2, we want to go to label 1, somewhere down here. Then we have two more instructions. So in cycle 1, we fetch the branch. In cycle 2, we fetch the subtract. In cycle 3, we fetch the OR. Then in cycle 3, we discover that the branch should be taken. And we actually want to go down and fetch this add instead. But the subtract and OR never should have happened. So we need to flush the two instructions after the branch. This is throwing away work. It's known as a branch misprediction penalty, and it's the number of instructions that have to be flushed when a branch is taken. So let's take a look at the logic to do flushing. So we need to flush when a branch is taken in the execute stage. We need to flush the instructions that were in the fetch and decode stage. And we're going to do it by adding flush D and flush E signals to as clear inputs to those pipeline stages, and we will flush in the decode stage if we're taking a branch. We're taking a branch if the PC source signal was asserted in the execute stage. That told the PC mux to take the value from the branch instead of PC plus 4. Then we flush in the execute stage if PC source E was true. That was happening if we're taking a branch, or if there was a load word stall that we already realized we had to flush the execute stage on a load word stall. So this introduces a little bit more hardware. We take a look at this PCE signal saying a branch is occurring, and if it does, we need to assert flush in the execute stage, which we already had, but we also need to add another flush for the decode register to that enable. So putting this all together, here's our complete processor with the data path, the control, and the hazard unit. The data path was essentially the same as the single cycle processor, except we've added some forwarding multiplexers for performance. The control was the same as the single cycle processor, except we pipeline along the control signals to the appropriate stages where they're needed. And the hazard unit is looking out for hazards. If they can be resolved by forwarding, then we enable the forward muxes to do that. Otherwise, we might have to flush, and so we could flush the stall or flush. So we can stall the early stages, flush the execute stage, and if it's a branch misprediction, we also flush the two instructions after the branch.